All right, so we're still in the Chapter 10 problem set. And now I'm going to go over questions number 10 and 11. So both of these questions have to do with the confidence intervals. So I'm going to start with question number 10. Now, I have some information here. I have my two sample sizes. So I have a sample size of 25 and a sample size of 30. Oh, wait. Let me try another version. I got that one wrong. Okay. So I have two sample sizes. I have one sample size of 35 and a sample size of 40. And I have the average for each group and the standard deviation, the average and the standard deviation for each one. And so I can go back to the PowerPoint to remember the formula that I have to do. So the formula is, it looks very confusing, but basically I just take my mean difference and then I add and subtract this interval range. To find the interval range, I take my t value for the confidence interval, so how confident do I want to be, and I multiply it by my standard error. So standard error, remember for this chapter, has a very long label, but I don't do anything with the M1 minus M2, it's just part of the label. Okay, so before I can calculate the standard error, I have to first calculate pooled variance. So I have some formulas here to calculate pooled variance. Pooled variance is the sum of squares of group 1, the sum of squares of both groups divided by the degrees of freedom of both groups. Now remember that the question gives us the standard deviation, not the sums of squares. But to get the sums of squares from the standard deviation, you take the standard deviation and square it, and then multiply it by degrees of freedom. So I'm going to start by doing that. I'm going to take my first standard deviation of 237. I'm going to square it, and then multiply it by my degrees of freedom. So that was my group 1, because it says standard deviation for group 1. My sample size for group 1 was 35, so the degrees of freedom is 34. My second group had a standard deviation of 256. And I'm going to square that and then multiply it by the degrees of freedom of 39, because there's 40 people. And this will give me, wait, 39. I said it right, but wrote it wrong. So this will give me my two sums of squares, and then I can divide it by the 2 degrees of freedom. So let me do that real quick. 34 plus 39. That's my 2 degrees of freedom, so that's 73. Okay, now let me calculate my sums of squares. So 237 squared times 34. I get this enormous number. I'm actually just going to copy it instead of writing it down. Okay, and then I have 256 that's not what I meant to do. 256 squared times 39. I get this other huge number. So now I'm going to add it to the one I calculated a minute ago. And I get 4,465,650. Whew. So I'm going to divide that by my degrees of freedom, which is 73. And I get this really big number, 61,173. So that's my pooled variance. Now I can take that number and plug it into my formula for the standard error. So I take that number and in turn divide it by each n. Okay, so my first n was 35 and my second n was 40. Okay, so I'm going to take this number divided by 39, and I'm going to write that down, 1568. And I'm going to add it to the next number divided by 40, or the same number, my pooled variance divided by my next n, and I get 15, this number. I'm going to add the number I calculated a minute ago. And I get 3,097.825. And the final step is to get the square root. So the result is 55.66. We'll see if that's here. 50, wait, what was it? 55 points, well, this one's kind of close, and it could have been because I did not write a lot of the decimal places. So let me see if some of the other answers turn out right, and then I'm going to assume that it's 57.25. Okay, so first of all, I need to find my confidence interval range. So I'm going to choose a t-distribution. I need to set my degrees of freedom. My degrees of freedom are my two n's added together divided by 2. Minus 2, because I have to subtract 1 from each one. So it's n minus 1 and n minus 1. So altogether it's 75 minus 2, that's 73. And I want a 95% confidence interval. So I need to find the t-value associated with the 95% confidence interval. So I'm going to watch this middle blue number here as I move the bars out, and I want it to say 0.95. And I can see that my t-value is 1.993. So remember, in the formula, we need to take t times the standard error to find our range. So I'm going to take my my t-value of 1.993 and multiply that by this standard error, 57.25, and I get 114.09925. So that is my interval range. Now the next step is to add and subtract that from my mean difference. Okay, so let me find my mean difference. So here's one mean, here's the other mean. So I'm going to do 24, 23 minus mean 2 of 26.79, and I end up with this mean difference, negative 256. So my confidence intervals are my mean difference minus the interval I calculated a minute ago and plus the interval I calculated a minute ago. So first let me do the minus, and I get negative 370. Let's see if that's an answer. Okay. Now I need to go back to my mean difference. And this time I'm going to add that number that I calculated a minute ago. That's my interval number. And I got negative 141.9. So that would be negative 142. Okay, so because that's the 95% confidence interval, I am 95% confident that the unknown difference, that the real unknown difference lies somewhere between these two numbers. Okay, so next I'm going to create a 90% confidence interval. I already have my standard error, so I don't have to calculate that again. But I do need to change my table here so that it's a 90% confidence interval. So I want this middle number to be 0.9, which gives me a new t-value. So my new t-value is 1.666, and I'm going to multiply that by my standard error. Remember, so we take our t-value for the confidence interval times our standard error, and we get the range, the interval range, that has to be added and subtracted to the mean difference. Okay, so there's my interval range, 95 point, all those decimals. And I'm going to go back to my mean difference. And this time I'm going to subtract my new interval range, the 95, and I get negative 351. Now I'm going to take that same mean difference and I'm going to add my new range, 95 point, all the decimals, and I get negative 161. So if in a 95% confidence interval, it ranged from negative 370 to negative 142. The 90% confidence interval ranged from negative 351 to negative 161. This means that I'm 90% confident that the unknown difference lies in this range. Now, if you look at the numbers, you'll notice that the 95% confidence interval is bigger, right? And so the new confidence interval is narrower than the original one because the new level of confidence is less than the original one. Now, let me see if I got them right, hopefully. Yeah, I got everything right. Now, one thing that you want to look for is you want to make sure that your range does not include 0. If it includes 0, then it includes my null hypothesis, which leads me to question 11. So in this question, they've already done a lot of the work for me. All this is the same sort of thing, but they've already given me my mean difference, and I just have to plus and minus my interval range here. And I have to see if 0 is included in that range. So they've done most of the hard work. I'm just going to take 1.31 minus that interval range, 1.9621. And I see that I get a negative number. Now, if I were to take the same number and add, it would be positive. Therefore, that confidence range includes 0. So the null hypothesis has to be rejected. It cannot be rejected because the difference of 0 is included in the computed interval. Therefore, I would conclude that there is not a significant difference in the two groups because my interval range in this way would include 0, which is my null hypothesis. So if my interval range includes my null hypothesis, then I cannot reject the null.